So in today's lesson, we're going to be learning about the formal definition of a derivative. And in your words worth knowing, I gave you a general definition of a derivative. It just means the slope of a function at any given point. So we worked with this a little bit yesterday where we had the parabola and we approximated the slope of the tangent line at the point 2, 4. And so that's what a derivative does for you. And then on the back side of that page, we did the slope formula in a general sense with no numbers. And we came up with something that we can use time and time and time again. And that's what we're going to look at today. Another important word that you might hear is the word differentiation. And differentiation just means the process of finding a derivative. So you wouldn't technically say derive. You could, but another word for that is differentiate. And that's the word that a lot of math teachers use. All right, so let's go ahead and get started. On the top portion here, we're just going to familiarize ourselves with the formal definition of a derivative. You can see when you open up that I have it written out for you. So the derivative of f, that's your function, at x, a given point, is given by this formula, so long as the limit exists. So this is the important formula that you will need to have memorized to be successful on this skill. And we developed one yesterday for my 4th hour. This was exactly the one that you developed. And for my 3rd hour, we developed one that was a bit different. We had a negative down here and a negative in our change of x. But regardless, both of those formulas would give you the same result. However, mathematicians have decided arbitrarily that this is the one that they want everyone to memorize. So there's a couple notes here. First of all, f prime, that's what this little apostrophe means when you read it. F prime is a function of x. So that means that this whole thing here is still a function. Whenever you simplify it down, you're going to have a function with x variables in it. But then you eventually plug in a number, and that gives you the slope. So f prime is a function of x. This new function gives the slope of the graph f at point x comma f of x. So this just means to actually find the slope, you have to plug in x. So to find slope, plug in an x value. If you don't do that, you'll just have a function. So let's do an example. Find the derivative of f of x equals x squared. And we actually did this in our activity yesterday, but we're going to go ahead and do it again for practice. So we look at our formula over here, and we're going to start by writing f prime of x. So that denotes that we're doing the derivative. It's different than just the regular function. Then we're going to put equals, and we have to include that limit notation. I will take off points if you don't include the limit notation. So it says f prime of x equals the limit of, and then this whole fraction here. Well, f of something simply means that you plug in what's in the parentheses for x in your function. So I'm going to highlight that. I'm going to highlight that this inside my parentheses is what I plug in for x in my function. So instead of writing this again, I'm going to write what f of x plus delta x actually means, which is x plus delta x quantity squared. You can see that I just took this blue here, plugged it into my function, and wrote down the function there. And then it says minus f of x. Well, f of x equals x squared, so we'll just write that. and then it's all over delta x. Nothing to do different there. And then we will simplify. Now I wrote this a little bit way too big. So I'm going to try to go over here a little bit. And I've got the limit as delta x approaches 0 of, I'm going to square this quantity, which means I need to double distribute. And that means I'm going to have x squared plus 2 delta x plus delta x squared. And if you don't believe me, on the side of your page you can go ahead and FOIL that out. But this is what you will get. And then minus x squared all over delta x. There's some condensing that can be done, so we can, we notice there's an x squared and a negative x squared. We can cancel those. And then we also see that every term here has a delta x on top and bottom, so we can cancel those. One here, one below, and we end up with, excuse my poor formatting, we're going to end up with the limit as delta x approaches 0 of, and what's left on top? Looks like I have 2 plus delta x. Oh, okay, I know what's wrong. Whenever I double distributed, I should have got 2x delta x for that middle term. Since it's 2x right here. And now we're going to actually evaluate our limit. So limits can easily be evaluated or determined by just doing direct substitution. So as delta x approaches 0 means we plug in 0 here, and our limit actually equals 2x. So this here is the derivative. And at that point, you can plug in any x value and find the slope at that point. So yesterday our example was at 2, 4, so we plugged in 2 and we got a slope of 4. If you wanted to know the slope at the point -12, okay, where x value is -12, then you would plug in -12 and the slope would be -24. So that's how a derivative works.